You're not going to want to miss this episode of the AI Show where Rajesh tells me all the secrets that Bing Ads uses to make your ads make even more money. It has to do with AI. Make sure you tune in. Hello and welcome to another exciting episode of the AI Show. I've got my friend here, Rajesh. How you doing, my friend?
Awesome. How are you?
Good. Tell us what you do.
I'm a senior product manager in Azure ML. I help my customers get their data science problems solved through Azure ML.
And this is a very problem-specific episode. We're going to go through like a very specific problem and how to solve it in the data science way and how AML helps. So let's start with the actual problem. What are we trying to solve today?
So we are working with closely with our Bing Ads team, and we're trying to help them to get a recommender system, a recommendation report out to their advertisers to make the advertisers successful in their digital marketing.
So let me see if I understand this right. It's like we're trying to make a recommendation system for people that are putting ads on Bing, and we're recommending to the people putting ads on how to do their ads so that they can make more money.
Correct.
Basically. It's not, because when I heard recommender system and ads, I thought like, where are we going to put ads on the Bing page? No, this is for actual advertisers.
Correct.
Okay, that's a little bit different.
Yes.
So why is it kind of a challenging problem?
It's challenging because first of all, as a customer, as an advertiser, everybody's trying to maximize their digital marketing budget, and they kind of come up with a list of keywords, a list of ads that they want to actually bid on, but they really don't know what's going to work and what's not going to work.
Right.
And they don't end up necessarily maximizing their digital marketing budget.
So let's talk about the data science problem, because I imagine like if we're recommending stuff to the advertisers, there's got to be like some ginormous corpus. Let's talk about the scale of stuff and let's get into the data science problem.
Absolutely. There are roughly, we have about, this specific problem is telling the advertisers which keywords to use to boost their ads and to boost the clicks on their ads. And we basically use light GBM, we use some clustering and come up with what other advertisers are doing for similar products, which ones are getting more clicks, which ones are getting less, which one are being seen more often, and so on and so forth. And then we come back with what is the recommendation for this advertiser if they use these keywords, if they place their ads in this particular way and use certain text recommendations, then they basically get a boost in their clicks and views.
Is this what we're looking at on the screen then? Is this an example of this kind of, this report?
Exactly. This is what the advertiser actually sees. So they can actually see that if they can boost their ads by positioning it, they can increase their number of conversions by running it on certain days, and they can also get their ads in front of more customers by adding new keywords. So there are different recommendations we have for the advertisers.
That's pretty impressive. And so again, we talked a little bit about the models. Like, are we talking like gigabytes, terabytes of data? How much data is actually being run when this is trained?
Usually it's in terabytes.
Okay.
Yeah.
And so let's talk a little bit about like how Azure Machine Learning Service helps now, because obviously there's a lot of options when you're using Azure Machine Learning Service. There's a training aspect, there's a model management aspect, there's a endpoint actually serving the things out. Which part of Azure Machine Learning Service did they choose to use, and how did it help?
So mainly our Bing Ads customers are using Azure ML for inferencing. So what they do is they do their offline training because there's lots of data and the data is stored right now in their own data centers. But they come back and they say they want to scale up. They want to make it. They want an easy way to package their model. They want to scale up, scale down on demand, and then they want to deploy it in Kubernetes cluster, and that's what we help them do. So, and that's pretty much like for them, they don't have to write lines of code. Instead of that, they're just writing a couple of lines of code and getting it done. And most of the infrastructure monitoring, scaling up, scale down, model management, all of that is taken care by in Azure ML.
So let's talk about this a little bit more precisely, because I feel like there's a lot of concepts that went in there. Let's talk about primarily what model management is, and then what it actually means to make a deployment in Azure Machine Learning Service. and why they don't have to think about all this extra stuff. So let's talk about model management first. What does that mean in Azure Machine Learning?
So model management is similar to software management. When you have a software component, you're doing versions of your software or your models, and then you're trying to understand how your model is performing. If it's not performing well, what are the reasons why it's not performing? If you want to basically understand that sometimes it didn't work well and you got some kind of escalations, what really went there? Was it data issues? Was the training not correct? Or did something happen within the model that actually went wrong? So you need to have the versioning, you need to have the capability of figuring out what's behind the scenes and quickly debug that and get something corrected out quickly.
I see, because usually, like, I'm being honest here, like I would just make a model and then we put it out on the server, but now with model management and Azure Machine Learning Service, you're able to say, we're using model version 7,
exactly,
for example, and if that model starts performing really bad, it'd be like, hey everybody, we got to pull the plug, let's go to 6 while we make 8 better, right?
Exactly.
Especially when you have like data drift, for example, which is really easy, or maybe you're having, because this is going to start to happen, I feel like people are going to start to understand your models and maybe start to attack the model with the wrong data,
exactly,
which is like, oh, so being able to version models is super important. So we talked about models. Now, how do we go from models to this easy deployment that you were talking about into Kubernetes?
Sure. So the Kubernetes deployment is pretty much like a few lines of code for data science. Basically they'll hand it off to their software engineers to do. From there on, we basically scale it out. We take their model, scale it out in multiple clusters. We have to understand how GeoRep will work in that case. And then we would make sure that it's ready for inferencing. For example, our current scale is we do about roughly 300K inferences per day.
Okay.
If you had to even provision for that, you would basically have to first you have to get hardware in, you have to provision the hardware, you have to basically make the container packages correct on all the versions of the compatible softwares. We do all of that. And currently this is being consumed by close to 500,000 advertisers.
I see.
So the scale is huge, and basically it takes away the load of doing the infra and the platform part from the developers and data scientists, and they focus on the business results more. So now they can do more of such capabilities for their customers to make them successful versus focusing on the infra.
Got it. So I imagine that in Azure Machine Learning Service, there's got to be some button that says, this model, I want to deploy it.
Yes.
And when you do that, what do you have to tell it? Like, because I mean, like when I have let's just say I have a raw protobuf file that I train in TensorFlow, there's usually some code that I have to load it up, right? Or let's just say I have a PyTorch, PTH file that I load up, and I know how to, because I'm more familiar with PyTorch at this time. Usually there's some code that I have to write to do the inferencing. Like, are you like hijacking that from me, or where's that code coming from to do that inferencing?
The code is pretty much like pre-built in. So basically what you're doing is you're giving us your model, and then we are basically packaging it and creating a web service out of it.
Got it.
And deploying it. So you don't have to do anything on your side. You're just saying, hey, just deploy this model. It's basically a few lines of code with some parameters. Mm-hmm. You will give a scale, how much scale do you want on the infra, on the resources, and you're done.
That's pretty amazing. Yeah, and I kind of teed him up on that one because I've done this before. Basically, you just have to say what environment and how to score it, and that's basically it. It's pretty amazing. I've deployed stuff out to Kubernetes, and like I said, Kubernetes is hard, and it's really nice to have it managed. Is there anything you would like to add? Where can people find out more about this?
Sure. I think I would say there are a lot of resources available on azure.com and azureml.com. So go to the website, look at tutorials, a lot of code on GitHub, try it out yourself, give it a shot, and we are here for feedback as well. If you find something that is missing, happy to take feedback and do better on that.
Fantastic. Well, thanks so much. Thanks so much for watching. This has been another episode of the AI Show. We've learned about how to deploy models out using Azure Machine Learning Service. Thanks so much for watching, and we'll see you next time. Take care.